There we go. That's better. We'll get started here in a minute or so. Okay, I think I'm going to go ahead and get started. Let me share with you my screen. Can everybody hear me? Give me a thumbs up or something if you can hear me. Yeah, okay, all right. Liam, can you hear me? Thumbs up at the very bottom. It says react. There you go. Okay, thanks. All right, so let me share my screen with you. All right, so today, all right, so we are still working on worksheet 4, and the learning target is that we can use the mathematical model for the net force to solve for missing quantities. So let me click on worksheet 4. And in period 1, you'll see the, or excuse me, period 6, you'll see the folders for each of you, okay? So you'll be able to click on it and go in it. So you can go ahead and do that if you want. Okay. So where's my, I can't find. Ah, there they are. I couldn't find where mine are. Okay, so I believe we've done problem number 1 already for this, and I just want to remind you what it is. It kind of gives you a force diagram, and on the force diagram, there's a bunch of blanks, okay, and we have to fill in the blanks. We have to figure out if it's balanced or not, and in order to figure that out, we're going to be using these two equations. Net force is equal to ma, and the weight, Fg, is equal to m times 10. So it gives us the mass here. I'm going to put this red box around it. So it gives us the mass. That means we can actually calculate what the force of gravity is by using this equation down here. So force of gravity is equal to mass times 10, plugged in the mass of 45, and got 450. So you'll notice that the force of gravity, that's the first blank I filled out, was 450. The normal force is balanced by that because for each one of these, it's like an object being pulled across a horizontal table. It says right up here, it's horizontal, or I guess horizontal floor. And so that means the normal force must also be 450. So that was the second blank I filled out. Okay, then after that, I had to figure out what the net force was. And notice I have 450 down, and then I have 450 newtons forward. I have 15
Please
newtons
go with.
right, which is going to be to the left, and I have 15 newtons to the right. That means all the forces balance out, and so the net force is 0. If the net force is 0, then by using F net equals ma, the acceleration is 0. And then finally, like we said, it was balanced. Okay, so you guys are going to be doing problem number 2 then. So let me stop sharing, and let me go ahead and put you in your breakout rooms. And let's see. Oh, shoot. All right, so I think I should be able to open them up now. Some of you might have different partners because not everybody came today. So the reason I'm putting you in these groups is so you can talk together while you're working on problem number 2. So let me go ahead and open it up. Should get an invitation. Go ahead and join it. If you don't get an invitation at the bottom where it says breakout room, you can get it in there. So Liam, you're in breakout room number 4. If you're not getting an invitation, there you go. You guys doing okay?
Yeah, we're just sharing screens right now.
Oh,
You
so
see it?
have you guys already done number 2?
Yeah, we've done. I worked ahead a little bit last time, so I got all the way up to number 4 done.
Okay, so can you tell me what you got for number 2 for like, tell me what you got for friction?
Oh, I thought you said number 5. Number
I
2.
I didn't catch last time how many you wanted us to do. So I just did up to number 4. That's
Okay, that's fine. So what'd you get for friction for number 2?
Go back.
for friction.
Yeah.
0.48.
Hmm. I don't know. Can you share that one, Eric? Can we see it so that way I can look at it?
Hold on.
Do I have to stop my share to do that?
Yeah, I think you do.
All right.
Stop. Does he stop screen sharing it?
Yeah,
Gotcha.
yeah, he stopped screen sharing. Now you screen share, Eric. At the bottom, hit the green screen share and hit the blue button that pops up.
Which blue button? There's 2. Share and screen.
You should see a bright blue button that you just, soon as you hit the green one, then there should be a blue button you hit.
I guess it's share. Okay.
Okay.
Is it working?
Yep. Okay, let me look at it there. So, okay, so everything looks good except for the friction, Eric. So everything looks great. So here's what you need to write. So can you write an equation there on your whiteboard? Do you see up above where there's a little T inside of a box where it says under there, right there, click that and then drag, yeah, right in there. Let's write an equation. So write F net. So F net equals F pull minus F friction. Okay, now stop for a second and just after you write that. Okay, now just look at your force diagram. I'm hoping you can see how it says it's accelerating. So it's accelerating toward the right, which means the pull force has to be bigger than the friction. Do you agree?
Yeah.
Okay, so that's how I was able to write that equation. I know that the pull force has to be bigger than friction. That's why I subtracted it that way. Okay, so now on your keyboard, hit enter, so it goes down a line. Okay, then you just found the friction, so it's 39.36. So type in 39.36 there for the net force. Equals, it says the pull force is 50, so put 50. And then minus F of, you don't have to write all of friction, you can just go fric, F, so minus F fric.
Where in the next line?
No, right there, just put minus F fric. Okay, so if you want to solve for the friction, that's the only thing you have wrong that you need to fix, is you
We'll
need to do,
subtract 50 on both sides.
say that again?
Subtract 50 on both sides.
Yeah, so you just have to do 50 minus 39.36 on your calculator, and that's your answer. Okay? Okay, I'm going to take off. So did you guys get an answer?
Yeah.
What'd you get for the friction?
10.
Yeah, good, nice, okay. So did you guys get an answer?
No, I didn't.
Did anybody get an answer?
No.
Well, somebody want to share their screen so I can look at it and I can help you? So the way you do that is at the very bottom, hit the green share screen and then click the blue share.
I'll do it.
Okay.
I didn't have much, but I think I figured out F net.
Okay, so now wait a second here. The mass there is not 820. That's what the force of gravity is. But Ryan, if the
Yeah.
force of gravity is 820, wouldn't the normal force also be 820? Yeah. So Ryan, could you move your 820 there that you put in the, yeah, put it up there for FN.
Okay. Wait, how do I? Okay.
There you go. That's 820. Okay. Now, Ryan, do you see up near the top, there is like it's where your tools are at the top of the page there. There's a T inside of a box. Click that T inside the box thing. It's almost right. It's almost where your cursor is, just down a little bit and to the left. No, you went the wrong way. So up, you'll see a T inside of a box. You see that ribbon right? Keep on going to the left. Keep going, keep going, keep going. Right, yeah, you went past it. You went past it. A little bit to the right. There it is. Click that. Okay, then over to the right. Click over to the, yeah, right in that space there. You're going to write an equation. So write FG equals M times 10. And then hit enter. Okay, look at, no, wait, go back. Why'd your cursor move? There you go. We know what FG is. If you look at the picture, it's 820. So put 820 equals M times 10. Okay, so now we need to solve this. So how do you solve that?
We need 10 times 820.
No, no, no. We need
What?
to get the M by itself. How do you get rid of the 10?
Subtract or divide.
Divide. So divide both sides by 10. So what's 820 divided by 10?
Let me get my calculator.
Okay.
Wait, can you do the calculator thing? Oh yeah, I forgot you could do it on the computer.
So 820 divided by 10. So
82.
So that's the answer. So go back to put M equals 82. So now in that blank, remember where you had 820 a little bit ago? That should have been
Yeah.
82. So right there in the middle where it says M equals, put 82 there. There you go. Okay, your net force is not right either. So in that same box, yeah, right over there where you have, yeah, that should be 82 times 0.48. So now on your calculator, go ahead and figure out what that is. 82 times 0.48. Oh, no, no, you got 0.048. You want 0.48. There you go. 39.36. So the decimal's in the wrong place. 39.36. Okay. So over there in the blank, you see kind of in the middle of your page, you got 393.6. That should be 39.36. There you go. Now we only have one more blank to do, and that's friction. So we need to write another equation, kind of like you did for FNet and also for FG. There you go. Yeah, click that, and somewhere where you have some blank space. Good. So here's the equation. So type this equation. FNet equals, and it's going to be, if you look at your force diagram, it's going to be the pull minus the friction. So F pull minus F friction, or F fric. Good. So hit enter, because you have to go down. You have to go down one line. So hit enter. Okay. We just found the net force. Remember that was 39.36.
Yeah.
Equals, well, they tell us what the pull is. It's 50. So 50 minus, so 50 minus F fric. Okay, so how would you solve for F friction?
I don't know.
Okay, so can you see that the friction's got to be smaller than the pull?
Yes.
When the pole's 50, so I think what we have to do is we have to subtract those two numbers. You have to do 50 minus 39.36.
10.64.
That's it. That's the friction. F friction is 10.64. That's the answer. That's what goes in the blank there. Then I'll leave it up to you guys to figure out if it's balanced or not. Okay, so see you later.
Okay, thank you.
What is it? There we go. Anybody want to share their screen with us so we can see how you got your answer? Anybody feel confident? Okay, so I'll share mine then. You check your answer. So this one was kind of a tough one. We didn't know any of these blanks here. Okay, so the first thing I did was notice that the force of gravity down here is 820 newtons. So that means I can use the equation Fg equals mg, or excuse me, m times 10. I know the force of gravity is 820, so I could solve for the mass, and I got 82. I guess I could have also figured out the normal force because those two would have to be balanced. The force of gravity and the normal force have to be balanced, so that was pretty easy without doing any math. Okay, the next thing I did was figure out the net force because F net's equal to ma, and I now know what the mass is. It's 82. It tells me what the acceleration is. It's 0.48, and so I got a net force of 39.36. Okay, probably the hardest thing is figuring out what that friction force is. So if you look at the force diagram, the pull force is bigger than the friction force because it's accelerating. So I wrote F net equals the pull force minus the friction force. So it's 39.4 equals 50 minus the friction force. And then solve it, and I got a friction force of 10.6. So the last question I have for you guys is this, and you guys need to unmute yourself so you can answer this question. So is this going to be balanced or unbalanced? Couldn't hear you. Unmute.
Balanced.
I'm sorry.
Balanced.
Balanced or unbalanced? Sorry.
Balanced.
Balanced.
Balanced. Okay, well, here's the acceleration. It's accelerating.
Well,
Balanced?
I thought
Unbalanced.
It's unbalanced, right? It's unbalanced because it's accelerating. It's unbalanced.
that because the force of normal and the force of gravity were equalized, it was balanced.
Well, you're right. That part's balanced. The normal force and the force of gravity, those two are balanced, but the pull force is bigger than the friction force. So overall, it's unbalanced.
That's what confused me.
Yeah. Okay. Let's try the next one. If you could please go ahead. I'm going to open up and you're going to do problem number 3 now. So let me open up the breakout rooms. Why is it always doing that? I don't know why. 30 seconds. Okay. There you go. Should be getting an invitation. Shane, you should get an invitation to breakout room number 4. If you don't get one, at the very bottom, there's a button you can click on for breakout rooms, and you can just put yourself in breakout room number 4. I know you're probably not all done, but I did kind of want to move things along a little bit here. So let me go ahead and show you. Hopefully you've done it on paper or somewhere as I asked you to work ahead a little bit. And if not, hopefully you got something on your paper you can, or on your whiteboard, you can kind of compare to mine. So let me share my whiteboard with you. So you know what? I think what I'm going to do is I'm going to kind of blank out my answers here. Okay. I didn't do that. Let me go ahead and blank out all my answers. That way you can see how I did mine step by step.
This one I didn't feel like gave me enough information.
Okay, so this is the only information you had. You have the friction force, the net force, and the gravity force, right? So again, I want you to, I think maybe I need to draw a picture. Let me draw another square, but this one I'm going to make red. Okay, so this one here, or black, how about black? I like black. Right, so this one here is a box we're kind of pulling to the right. Okay, so it's moving along this floor toward the right. So that normal force has to be the same as the gravity force because it's not going up or down. So that one, I can get that answer right away. No work,
Yeah.
no calculation needed.
In math, I got pretty easily as well. Just
Yeah,
divide force of gravity by 10.
that's right. Yeah, that's what I did next. I said force of gravity is equal to m times 10. And so I took 49 divided by 10 and I got 4.9. So that was the next one I did. That was pretty easy. Okay, the next one I did, believe it or not, was to figure out the acceleration because it tells us what the net force is right here. It says the net force is -10. So I figured out what the acceleration was next. F net equals ma. The net force is -10. I just found the mass is 4.9. And so I found the acceleration to be -2.04. So the last one I found was actually the pull force. And I want you to see this. It says the acceleration is -2.04. That means it's actually slowing down. In other words, the pull force must be smaller than the friction. So when we're pulling this object over to the right, we're actually not pulling very hard. It's actually starting to slow down. So that means the pull force has to be smaller than the friction. If you want to know how much smaller, well, it's going to be the same amount as the net force smaller. So here's my equation I wrote. F net is equal to the pull force minus the friction. Well, the net force is -10. So it's going to be pull force minus 15 because the friction's 15. And then I'm able to solve for the pull force and I get 5 newtons. So notice the pull force is actually smaller than the friction force. And so it starts to slow down. So I need you guys to unmute yourself. We have to answer one question together. Is this balanced or unbalanced? So count of 3. 1, 2, 3. What is it?
Unbalanced.
Balanced.
Right.
Unbalanced.
Unbalanced. I think most people said unbalanced. You're right. Unbalanced because it's accelerating. It's slowing down in this case. It's unbalanced. Okay, we're gonna do one. Let's see. We're gonna do another problem pretty quickly here. If you could please do number 4, please. Number 4. Let me go ahead and open up the breakout rooms.
Okay.
There you go. So did you guys, how you doing? You have an answer? You have to unmute yourself. I can't hear you.
Almost.
Almost, okay.
Yep.
Are you guys working together?
Not really. I
don't think you guys get what what I'm trying to do. I kind of want you guys to talk in here. I mean, trying to make it somewhat interesting, that you can talk with people you see every day, or you used to anyway, and maybe see one another and work on the problem together and stuff. You can even work on the same person's whiteboard. You don't have to be working on your individual whiteboards. You can, so everybody could be in Haley's whiteboard this time. And anyway, that's what I would do. Oh, where's everybody at? Oh, there we go. Okay. Okay. So did anybody want to share their whiteboard with us? Okay. Let me share mine real quick. Oops, wait, sorry. All right, so I kind of covered stuff up again so that you can kind of see how we did it here. So there's only three things given to us: the normal force, the pull force, and the net force. Okay, and we have to figure out the other things. So again, this is an object being pulled, let's say, to the right. And the first thing I figured out was actually, I found the force of gravity didn't have to do any work because I know those two are balanced. After that, I found the mass. I use Fg equals m times 10, plugged in the force of gravity, which is 290, and solved for the mass, and I got 29. After that, notice they give you the net force here is 80. So that means the next thing I found was actually the acceleration, because I know that F net equals ma. So I plugged in the net force is 80. I plugged in the mass I just found was 29, and I got around 2.76, I think. Okay, then the last thing I found was the force of friction. So realize that the pull force is bigger than the force of friction. That's why it's accelerating. That's why it's getting faster. And if you want to know how much bigger it is, well, it's 80 bigger. So the pull force is 80 bigger than the friction. And so I just wrote an equation. I said the net force is equal to the pull force minus friction. The net force is 80. The pull force is 180. Solve for the friction, and I got a friction force equal to 100. Anybody get it right? Thumbs up if you got it right.
I got half right.
You got it half right, okay. So the question to you guys, is this balanced or unbalanced? So you have to unmute yourself. Count of three, balanced or unbalanced?
Unbalanced.
Balance.
Hey, nice, all right, unbalanced. Okay, so that's the last one we're going to whiteboard today, but what I'd like you to do is I'd like you to finish up by doing 5 and 6. In 5 and 6, it kind of gives you a story problem. So I'm not giving you the force diagram, you have to draw it yourself. Here's 5, 6 looks like this. So I'd like you to finish those up so you can whiteboard those on Monday, right? No, on Tuesday, excuse me, on Tuesday. All right, let me go back to the calendar here. For
Wait,
the
hold on.
people who weren't
Good.
able, question?
Could you go back to number 3 for a second? I didn't copy all that down.
Oh, number 3. Okay, hold on a second here. 3. Maybe do a screen capture. Can you do a snipping?
I mean, that would work, but I already got everything else,
Got it?
so
Okay.
I don't need one number. Thanks.
Okay. So you're doing 5 and 6 for homework. That way you can quickly whiteboard on Tuesday. So for the people who weren't able to attend the Zoom meeting today, they need to do the quiz. You guys don't have to do the quiz, but if you did the quiz, you can get bonus points. So I need to give you the code for the quiz. And the code is, the access code is 369-264-519. 369-264-519. Okay, I have to get attendance first, so don't take off. Let me stop sharing.
I do have a quick question while you're taking attendance.
Yeah,
One of the questions for those next two, it talks about equilibrium.
equilibrium means are the forces, it's another way of saying are the forces balanced or not. So if it says if it says that it's in equilibrium, that means the forces are balanced.
Okay.
Okay.
Yeah.
So you know how I do kind of a picture, and I have you turn on your camera so I could take a picture of you. There's one more thing I want to add to this. So everybody go ahead and turn on your camera. Okay, the one more thing that I want to do is, I've been doing it all week, it's kind of fun, is I would, actually not all week, just yesterday and today, is that I know some of you probably have a cat or a dog or some other pet at home, like a hamster or a goldfish or something. Why don't you go get your pet, and I want to take a picture of you holding your pet.
I think she's too big, but
Well, just, bring her over so we can see her face.
okay.
All right.
Wait, what? What do
If you don't have a pet, maybe you have your favorite, I don't know, maybe your favorite stuffed animal or something.
You guys just put her outside.
Wait a
Maybe
minute,
you
why
have
did you
a little
want that
baby
again?
brother or sister or something.
Why did you want that again?
I don't know. I just want to see. Pets are fun. Pets are fun. So Zakira, what's the name of your pet?
Her name is Paris.
Paris, nice. Sophia, what's the name of yours? Sophia, what's the name of your pet?
Bruno.
Bruno. Nice. Okay, and Alan's getting his, so let me get my snip. Okay. So, Alan, what's the name of your dog?
Lucy.
Lucy, nice. Okay, so,
Lucy.
oh, Braden, what's the name of your, is it a cat? What's the name of your cat?
Shut up, Anna. I'm doing work.
What's the name of your cat?
Smudge.
Smith, okay. Anybody else have pets to get?
I don't have any pets that I can bring. I
Well,
have
it's good to
fish.
see pets. Oh, Haley, what's the name of your pet?
Peter.
Say it again.
Peter.
Peter.
That's a cute name.
That's good.
I like
Okay, so count of 3. We're gonna take a picture. Ready? 1, 2, 3. Nice. Those are good pictures. Look at that. I love it. That's awesome. Okay. So that's it for today. So I'll see you on Tuesday, same time. So goodbye.
Yeah.
Bye.
Yeah. See ya.
Bye.
Bye.